All right, continuing with direction for no start diagnosis, section 22 is we're going to address now control testing with a test light. We're going to use a test light and we're going to determine whether or not we have control on a coil that does not spark. So control testing with a test light, starting on page 8. First thing you want to understand about ignition coils is the majority of them are ground side switched. I remember a 1984 Chrysler and about that old Mercedes-Benz that was a power side switched ignition coil. Every other system I've worked on since then, they're all ground side switched. So what you're dealing with a coil is very simply a ground side switched solenoid. If you want to think about it like that, section 3 when we went through power and ground side switching, ground side switch solenoid, and this is not really a switch, it's a transistor, but gives you a good perspective of what you should be looking for. And when I say using a test light, what you want to do first is check both wires, the coil positive and the coil negative, during cranking. And the reason I want you to do this during cranking, and it would be a test light on both of these, is in particular coil negative, that's this side of the coil. Coil positive is this side. This is the primary circuit. When that transistor or switch opens and closes right here, this test light should flicker on and off. When the switch closes, voltage drops in that control wire, and this test light should go out. When the transistor opens or the switch opens, that current flow stops and the light should be bright. So the test light should flicker on and off. And the idea with this would be if you have a coil that's not producing spark and your test light flickers on coil negative, that tells you have control and you probably, most likely, need an ignition coil. It's that fast of a test. Picture a single coil system. It can be a coil over plug too, it doesn't matter, or waste spark for that matter. That coil negative is pulsing on and off. Your test, as indicated by the flicker of your test light, that means that there's control in that circuit. If you have no spark coming from that coil, you need a coil. The reason I want you to do this cranking, and the reason why I want you to check the positive side also during cranking, is you need to understand that when you crank an engine over, your starter is producing those surges in current flow on the battery. And you have roughly 50 to 70 amp differences between the peaks and valleys of current coming from the battery going to the starter. What are those peaks and valleys going to do to voltage on the system while you're cranking? The voltage is going to follow that, and that voltage is going to drop for every spike in amperage. And so what that can produce for you if you're not careful is you may think that pulsing or that slight flicker of the test light is control on coil negative. So picture this, you check coil negative right here and the test light's flickering on and off. Seems to be. You mistake that for control, but what really is going on is system voltage surges from the starter. And so the reason we check the positive side and compare it to the negative side is so we don't screw that test up. They should look different from each other, distinctly different from each other. So that's step 1 if using a test light. You need to understand that you need to check the positive side to compare it to the negative side. Don't mistake starter current draw surges in the system as coil negative control. Okay? And so what I have here, again, coil negative pulses means there's control, you have a bad coil. Coil negative does not pulse. There's 2 different scenarios you're going to have. Either your test light is lit constantly, or the test light is not lit at all. That's what you're going to see. In most cases, what you're going to find is that you're going to have a constant light on coil negative. And again, it's a simple circuit. Your test light is connected to, and this is a transistor, we'll draw it that way this time. Your test light's connected to coil negative, and let's say that this light is lit. There is no flicker in that light. Means there's no control. If there's no control, that means that this transistor inside of either the PCM or the ICM, depending on where it's located, is not functioning. Constant light. So in this case, let me move this over so this isn't interfering with the words on the page. Let's go put this inside of the PCM. Test light's lit right here. Constant light. So you're cranking the engine over, no flicker in that test light. Your next easiest step, again, using the test light, is take that same test light, put it over here. If this test light, when you connect it over here, is not lit, what you have is an open in the control wire. If it's lit constantly, just like it was at the coil, the integrity of your control circuit is good, and then your focus goes toward this driver inside the computer that controls the coil. And what does that driver need to function? You need powers, you need grounds, and you also need inputs, and those inputs would be cam and crank. So that would be the direction you're going to when you have a test light that does not light. It's a constant, when you have a test light that is a constant light on coil negative. No light. Again, starting here, move your test light to here. If that light was off, you have an open wire. If that light is constant, as it was in this step, then you're dealing with powers, grounds, and inputs before you replace the module or computer wherever that driver is. The other scenario that you'll run into in this case using a test light would be no control, again, no spark, and what you find is your test light is not lit. So you go to coil negative and it's not lit. Well, you definitely want to make sure that positive in this case is lit, coil positive. So let's say coil positive, you got power, coil negative, you don't. That addresses the power side. Of course you want to do that. If there's no power on the positive side, then go find your blown fuse or broken wire. But if you have power on the positive side of the coil, coil positive, and no power as indicated by the light, not being lit on coil negative, there's a couple different scenarios. One of them would be there's an open in the coil. Another one would be there's a short to ground in the control wire, which would make that circuit be on all the time. And then the third one would be a shorted driver that is on all the time. And I'm thinking of the Chrysler, older Chrysler 3.3, 3.8 engines had this issue with the PCM where the driver would be on all the time. It was a faulty computer that would cause it. But what I would do to address this, an easy method, is it a short or is it an open? And really what you can do is isolate that by simply changing the polarity of your test light. At this point, connect your test light to positive. If that test light stays off when you did that, it cannot be these two. Because either one of these two, when you connect your test light like this, is going to cause that test light to light. If the test light is out when you connect it to positive at this point, what is your only possible scenario? Is an open in the coil. Okay? If the test light lights in this step, it's not going to be an open in the coil that I'm worried about. I'm worried about, is it the control wire? Is it the driver? And so it's really simple from this point. Turn the key off, unplug the module. If your light still is lit, your test light still lit, you have a short to ground on the control wire. If your test light goes out when you disconnected the module, you have a shorted driver. And so that's really what this is describing right here at the bottom. No light, definitely make sure you got power. If you have power, then you're either dealing with an open coil primary, a short to ground on the control wire, or a shorted driver, and I'm telling you what to do to address it. Connect your test light to battery positive. No light, you got an open primary winding. You got a light, shorted wire, or driver. And I elaborated on that a little bit more on telling you how to figure out which one it is. Shorted wire, shorted driver. This sounds a lot like section 3, doesn't it? With ground side switch solenoids, high voltage all the time, low voltage all the time. This is exactly the same kind of testing. Control testing with a test light. There's one last thing I want to mention, and then we're going to wrap this up. We'll do the scope stuff later. Is there's a variable to the test light. And that variable is when you have a completely shorted coil primary winding. And here's what can happen. I have a case study on this I'll show you later. But let's say that this coil winding is shorted. And normal current flow through the primary winding, it might be, say, 6 to 8 amps of current flow. And with a shorted winding, obviously, it could be unlimited and the wiring could burn out. But what happens if this winding shorts out is your amperage goes really high in this circuit. The driver is going to see really high amperage. And what it's going to do is protect itself from that high amperage. And it does that in the form of adding resistance to the ground side of that circuit. If you want to call it that, this is the ground side of the circuit. That transistor is going to protect itself and not provide a full ground. What that would look like on a scope, a full ground would go battery voltage, call it 12, and it's going to pull it to ground. And this would be the on time of the coil, or the dwell time, the amount of time that coil is energized. When you put a test light on that, what's causing that test light to go out and to flicker is this large drop in voltage. Now, granted, it's only momentary. You're only talking about a millisecond or two, and then it is going to give you that spike in the primary, and then the rest of this is your secondary feedback. But this section in here is what's going to make this light flicker on and off. And what happens when the winding is shorted is the computer will protect itself, and what it would look like is it only grounds it about that much. And you're really not going to have a voltage spike at all because there's no magnetic field that collapses. But the point with that is you may only be about 1 volt less than battery voltage. So let's say you're 12 volts here and you're 11 volts here. Is that going to make your test light flicker? Will you see a difference in the brightness of your bulb from 12 volts to 11 volts? And the answer is no way. You're not going to see it. And so what you're going to do is you're going to mistake that test light not flickering as no control. But when in actuality, there is control there. And so what I'm telling you is the test light is not foolproof. And the one exception to the test light not flickering and there still being control is a shorted primary winding. I'm going to show you this later. It's my coil overplug case study I have later in this section on Chryslers. I have a shorted coil, and I'll show you that condition. So it's not foolproof, the test light, but if that's all you have, it's helpful. It'll get you out of trouble. It'll give you some direction. I would encourage you to watch this video listed right here. It's a Subaru. I'm using a test light. In fact, we'll do that right now.